Hi everyone, this is Algebra 1, lesson 7-6. We're going to factor ax² plus bx plus c in this lesson. So in this lesson, you'll be able to identify the common factor of the coefficients in the terms of a trinomial expression when a is not equal to 1. We've seen polynomials when a is equal to 1, but now we're going to have a coefficient other than 1 in front of our first term. And you'll also be able to write a quadratic trinomial as a product of two binomial factors. Let's start with explore and reason. A website design company resizes rectangular photos so they fit on the screens of various devices. If you look at the picture, you have one side that is measured x plus 4, and you have another information, which is the area, that's x² plus 7x plus 12. So, because x plus 4 is the longer side, it is the length. Part A, what expression represents the width of the photo? The width will represent the shorter side, and we don't have that information. But looking at the given information, we'll be able to figure out the width of the photo. How do we figure it out? Yeah, we're going to factor out the area. And x plus 4 is one factor. The other one is our width, right? So in our previous lesson, 7-5, we learned how to factor polynomials, a trinomial, when you have 1x², right? So if you remember it, when you factor a form, a trinomial form of x² plus bx plus c, so b and c are numerical values, okay? They're numbers. You're going to have a factored form of x plus p times x plus q, where you have pq is equal to c in your previous trinomial, and p plus q is equal to b. So if you factor our area, you get x plus 4 and what? X plus 3. Okay, so when you multiply them, you'll get x squared plus 3x plus 4x plus 7, which is x² plus 7x plus 12, which is exactly what we want. So that is the factored form, okay? So which one is our width? Since our length is x plus 4, our width is x plus 3. Okay, part B, write 3 possible lengths and corresponding widths of the photo by substituting different values for x. So what if your x is 1? What if your x is 2? X could be any real numbers, right? Any reasonable numbers in this situation. So we're just going to pick random numbers and fill it in. So when x is equal to 2, the length is how many? Length is x plus 4, so 4 plus 2 is 6. Length is 6 units. And width is 5 units. And when x is equal to 5, length is equal to 10 units. Width is equal to 8 units. Okay. And when x is equal to 6, this is just random numbers, okay? It doesn't have to be 2, 5, or 6. You can pick your own number. You can pick 1, you can pick 7, you can pick 10, however you like, but your length and width have to be x plus 4 and x plus 3, okay? When x is equal to 6, length is 6 plus 4, which is 10. Wait, sorry. I think I didn't write the correct one for x is equal to 5. I got confused. That's 9 units, and that is 8 units. That's 10 units, and the width is 9 units. Okay, good. And you can keep going if you want to. Part C, why would the company use an expression to represent the area? So in this design company, they're going to resize rectangular photos, like make it enlarge it, or make it smaller. They're going to fit on screens on various devices like iPad or iPhone. Their screen sizes are all different, right? So that's probably where the company is going. The company might use a variable expression to represent the area because the area will change depending upon which device is displaying it. So that could be why. There could be another reason, but that's probably the main reason. So let's write it down. Okay, there we go. Make sure you write the notes down. So that was an introduction of our lesson. So the lesson's essential question is, how is factoring a quadratic trinomial when a is not 1 similar to factoring a quadratic trinomial when a is equal to 1? So how is it similar? How is it different, right? Let's look at example 1. Factor out a common factor. What is the factored form of 3x cubed plus 15x squared minus 18x? So now we have a trinomial that has coefficients for all the terms, right? So before factoring the trinomial into 2 binomials, look for any common factors that you can factor out. So before you factor it out using the complicated trinomial factorization that you learned last lesson, you're going to try to make it simpler so that it is easier for you to factor the trinomial out. So if you look at the terms and break it down, 3x cubed is actually 3 times x times x times x, right? 15x squared is just 3 times 5. So this is the prime factorization times x times x. 18x, 2 times 3 times 3 times x, okay? So you prime factorize the coefficients, and you're gonna break your variables down, okay? And so you can see there is a common factor of 3x. You see 3 and x in all of these terms, right? So you're gonna factor 3x out. And then if you factor them out, you're literally dividing 3x by all these terms, okay? Because when you factor it out, that means you're gonna multiply them in order to spread them out, right? So 3x times x squared should be 3x cubed. 3x times 5x should be 15x squared. 3x times -6 should be -18x. Does that make sense? Okay, and now you can factor the trinomial, and you don't have a coefficient. So you should know how to do that from the last lesson, okay? So looking at the factors of -6, you have 1 and -6, -1 and 6, okay? So those multiply to -6. But you're going to add so that you get the coefficient in the middle, +5. So -1 and 6 is the only combination that works to get a +5 as a sum, right? So this should be your factors, x minus 1 and x plus 6, okay? So that's just a factorization for the trinomial that was simplified, right? So 3x is still there. Don't just get rid of it. You have 3x times x minus 1 times x plus 6, okay? So it's not as hard as you think, right? You can first factor them out and make it into a trinomial that you can actually factor out. And then it's done, right? You can do it. So try number 1, you're gonna factor each trinomial. Please pause the video and solve parts A and B, and we'll check when you come back for answers, okay? Okay, are you ready? All right, let's look at part A. Is there any common factor that you can factor out first before you factor out the entire trinomial? We probably want to factor that 5 out, right? In order to make a coefficient 1 for your x squared, right? Yeah. There's no x in your last term, so you're just going to factor out 5. And if you factor out 5, you have x squared minus 7x plus 10. And you're going to factor out the trinomial, the simplified trinomial here. And what do you get? You should get x minus 5 times x minus 2, okay? Minus 5 times minus 2 is equal to positive 10. And if you add them together, you get negative 7. So those should be your final answer for your factored form. Okay, you need to factor out completely. If you factor out just 5, then you factored out, but you're not done. You didn't factor out the trinomial when it is still factorable. So you have to factor it out completely when they tell you to factor each trinomial, okay? That's the objective. Okay, let's look at part B. You have 6, 30, and 24 as coefficients, and all the terms have x in it. So you probably can factor out 6 and x, and that is correct. So if you factor out 6x, which is the greatest common factor of all these 3 terms, you will get x squared plus 5x plus 4. Okay, and then you factor out that trinomial, the simplified trinomial, and your 6x is still there, okay? Don't get rid of it. You will get x plus 4 times x plus 1. 4 and 1 multiply to positive 4, and they add up to 5, okay? So that is your final answer for part B. Check if your answers are all correct. If so, good job. If you got some incorrect answers, please look back and check how you could do it better next time. And make sure you get the skill down before you move on to the next example. Let's look at example 2 on the next page. Understand factoring by grouping. All right. So now we got the same form, ax² plus bx plus c. What if you can't really factor it out and simplify the trinomial, right? We're gonna learn something called factoring by grouping. Okay. We're gonna look at the values a, b, and c and how they're related. So first, we're gonna explore a little bit. We're not gonna answer this right away. We're gonna explore and try to understand the binomials and trinomials, okay? So first, let's consider this product, okay? This is just, you don't know where it's from, and that's okay, okay? Just consider this. 3x plus 4 times 2x plus 1. You multiply them, and you're gonna multiply using the FOIL method, right? First, outside, then inside. So you're going to multiply 3x times 2x, 3x times 1, 4 times 2x, 4 times 1. And those are your terms. And that means you have 6x squared plus 11x plus 4. Okay. And so the product is 6x² plus 11x plus 4. How are they related? You could see that AC. So in this form, you have ax² plus bx plus c. A is the coefficient in front of x², the first term. B is the coefficient in front of x, the second term. And c is the numerical term, okay? So a times c, this one, times this one. So 6 times 4 is 24, okay? Which is the product, that's the product of all the coefficients and constants from your factored form. Do you see that? So if you break down 6 and 4, you have some factors. 3 times 2 is 6. 4 times 1 is 4. And those are the coefficients in your factor. Do you see that? So this is one observation. In the middle step, the coefficients of the x terms, 3 and 8, in the second step, add up to get 11, right? So 3 and 8 are 3 times 1 makes 3, right? And 4 times 2. So the factors are also all part of, are all coefficients in the factored form. Do you see that? So the factors of your first and last coefficients should be the same as the factors that you add up to make this number. Does that make sense? So the middle step is a little bit more complicated, but you need to think about, oh, what two numbers add up to the middle number and also has the same factors of the first and last coefficient, okay? Those are the relationship that we observe. So if ax² plus bx plus c is a product of binomials, there's a pair of factors, a times c, that have a sum of b, okay? All right, so that's some observation that we make and see the similarities between the regular trinomial and the trinomial that has a coefficient other than 1 for your a. So how can you factor ax² plus bx plus c by grouping? So now we're going to look at grouping. This is part B. You're going to consider the trinomial 6x² plus 11x plus 4, the same trinomial that we looked at in part A. And your A is 6, C is 4, so AC is 24, right? We're going to find a factor pair of 24 with a sum of 11. Factors of 24 are 2 times 12 or 24 times 1, but that's not going to work because if you add them, it's 25 or negative 23. So we're not going to, yeah. That's obviously not close to 11. So we're going to look at 2, 12, 3, and 8, right? 2 and 12, if you add them, it's 14. And it needs to be positive 11. So we need to have positive factors, right? So 3 and 8, if you add them, it's 11, right? So we found it. We found the factors of 24, which is the multiple of 6 and 4, right? It's the product of 6 and 4, the last and the first coefficient, and sum of the middle coefficient, okay? So now we're going to rewrite 11x as 3x and 8x so that we have the middle form, right? We're trying to find this middle form, okay? And then we're going to group as two binomials. So we're adding the two binomials. You see that? You'll see why we're doing this, okay? We first group them. And then we're going to factor out the greatest common factor to make the binomial simple. And then we'll see the same factors when the binomials are simplified, okay? It doesn't always work this way, but a lot of times it will work as well. And then that just means you can pull 3x and 4 out and make it as a binomial times this. How can we do this? This is the reverse of distributive property. If you multiply 3x times 2x, 3x times 1, 4 times 2x, 4 times 1, you get the middle part, okay? So that's, yeah, these are the necessary steps that you need to take when factoring by grouping. So the factored, sorry, excuse me. The factored form of 6x squared plus 11x plus 4 is 3x plus 4 times 2x plus 1. Okay, that is the answer when you factor it by grouping. And you can always check if your answer is right. Don't just assume that your answer is always right because you might make mistakes in the middle. So you're going to check by solving out the factored forms. And if you get the same trinomial that you had in the first place, that means you've done it right. Okay, so this is a way to check. All right, so first, think about the factors of the product of your first and last coefficient. And then you're going to find the sum of that factors that make the middle coefficient. And then you're going to write that into a polynomial with 4 terms where you have 2 middle terms. And then you're going to group them and factor out the GCF, then use the distributive property to get 2 binomials. Okay? So follow these steps to try number 2A and B. Pause the video and try if you can solve it by yourself and come back when you're ready for answers. Okay, are you ready? Yeah, this is going to be a complicated one where there are many steps, but if you follow the steps one by one, you can do it. Let's look at try number 2A. Okay, you're going to factor each trinomial. So first, what is the first step? So first, your first step is to look at the product of the first and last coefficient. What is the product of 10 and 3? 10, so this is 2A. 10 times 3 is 30, okay? So we're going to look at factors of 30. And then that makes sum of factors to make 17, okay? So there are many factors of 30, 1 and 30, 2 and 15, 3 and 10, 5 and 6. It has to be positive 30, so we just need to look at positive 1 and 30, or, you know, negative times negative also works, but they're going to give you a negative sum, so we're not going to worry about the negative numbers, okay? So we have 1 and 30, 2 and 15, 3 and 10, 5 and 6. And some of them, if you add them, you get 31, 17, 13, 11. So which one has a sum of 17? 2 and 15, right? So you're going to rewrite this and break down your second term. 10x squared, instead of 17x, we're going to add 2x and 15x because that's the same as 17x, right? So 2x plus 15x plus 3. And then we're going to group them. 10x squared plus 2x plus 15x plus 3x, 3. So Some of you might wonder, what if I wrote 15x first and I wrote 2x first? That's okay. At the end, your factors are still going to be the same, okay? It's fine. Make sure you just factor it correctly. So if you have 10x squared plus 2x, your greatest common factor for this one is 2x, right? 10x squared has a factor of 2 and a factor of x. So you can factor out 2x. And you get 5x plus 1. Okay, 1 times 2x is 2x. Right? And then 15x plus 3, your GCF is 3. So if you factor that out, you get 5x plus 1. And you notice this is beautiful. 5x plus 1 is the same factor in both of them, right? So you're gonna use the distributive property to reverse distribute and factor out 2x plus 3, and that becomes a multiplication with 5x plus 1. And that is your factored form. You completely factored this trinomial. Okay? Follow the steps and it's going to be easy. All right, let's look at part B. You have 2x squared plus x minus 21. So what is your first step? First, you need to look at the product of 2 and negative 21, right? So 2b. 2 times negative 21 is negative 42. So look at factors of negative 42. And then you're going to look at their sums, okay? There are a lot of factors of negative 42, and you might want to look at negatives in either cases, right? Because because negative times a positive will make a negative number. So when you have a negative product, it's a little bit more complicated. But 1 and 42 is one combination to make a factor of 42, but they're not gonna make a sum even close to 1, right? Negative 1 times 42 is negative 42, but the sum is 41. And positive 1 times negative 42 makes negative 42 as a product, but the sum is negative 41. So it's not close. So let's start looking from 2 and negative 21 and negative 2 and positive 21. So if you add them, you're going to get negative 19 and positive 19. And they're not even close either. So let's look at positive 3 times negative 14 also makes negative 42, but that's going to be negative 11. Negative 3 and positive 14 is going to make positive 11. So let's look at the next one, 6 and negative 7, negative 6 and positive 7. 6 times negative 7 is negative 42. Negative 6 times 7 is negative 42. Their sum would be negative 1 and 1. Ta-da! You want the positive 1 because your coefficient of your second term is 1x. If you have a positive x, that is positive 1x. So your coefficient that you're looking for, the sum that you're looking for is 1. So your combination, your coefficients are negative 6 and 7. So rewrite your trinomial with breaking down your second term. By breaking down your second term, right? 2x squared minus 6x plus 7x will give you plus x in the middle, right? So we're not changing the polynomial. It's the same polynomial, but we're changing the form, okay? So that we can group them and factor them out. So group them out. Again, what if you wrote 7x first and then negative 6x on this last? It doesn't matter. You'll still get the same factor as long as you factored it out correctly, okay? So don't worry about that. So let's factor this out. You're gonna group it first, 2x squared minus 6x, and you're gonna add 7x minus 21. So factor out using the greatest common factor. 2x should be GCF for this one. And you have x minus 3 left out. 7 should be the greatest common factor here, and you have x minus 3 left out as well. What if you factored out a negative? Then you should factor out a negative on the second term as well, so that you make the same factors, right? If you have x plus 3 here and x minus 3 on the other one, you're close. You might have to factor out the negative, okay? Sometimes that would be the case where one is easier to factor out the negative and the other not. But anyway, you have to see the same term in order to factor out completely in your last step. So using the reverse distributive property, you can factor out 2x plus 7, multiply it with x minus 3. And that is your factor for the trinomial. Check your answers, see if you got everything right. And review if you haven't got everything right. Okay, let's look at the next example. This should be the last example for this lesson. Example 3, factor a trinomial using substitution. So this is another method to factor out. How can you use substitution to help you factor this form ax² plus bx plus c as a product of two binomials? So do you remember what substitution is? It is when you substitute a number to a variable, or you just substitute whatever that's different to another when they're equal to each other. You can substitute when they're equivalent, okay? So let's look at the trinomial 3x² minus 2x minus a for an example. Step 1, you're going to multiply the trinomial by a. So the first factor in front of x² to transform x² into ax². Does that make sense? So look at this example. You're going to multiply 3 out to the whole polynomial so that you have 3 times 3x², which is 3 times 3 times x, right? So if you have 3 times 3 times x, that's the same as 3x times 3x, right? Because 3 times x times 3 times x is the same as 3 times 3 times x times x. And that's equal to 3x, the whole thing, parentheses, square. Don't forget the parentheses, otherwise it's just 3x², and that's a different thing, okay? So then you just have to multiply 3 on the other terms to balance your polynomial and maintain what you have, okay? So negative 2 times 3x is your second term, and negative 24 is your last term, okay? Why are we trying to get this? Because we want to substitute a variable for 3x, because we have 3x factor as a factor, right? And we don't have 3x on the last term. But we can still try to use a trick in math where you substitute a complicated thing into a simplified thing, and then you can resubstitute it back later on. Okay, that's the plan. So we're gonna first replace ax with a single variable. So 3x is going to be whatever your coefficient is, it's gonna be a variable. Let's substitute it to p. And then we're gonna have p² minus 2p minus 24. And now that we look at this like this, it's simple. It looks familiar. It looks like a trinomial that we could factor it out, right? We looked at this form in the last lesson, so you should know how to factor this form. So you're gonna factor the trinomial. Look, thinking about the product of the factors of 24, negative 24, that add up to negative 2, okay? Which should be negative 6 and 4. Negative 6 times 4 is negative 24. Negative 6 plus 4 is negative 2, okay? So factor the trinomial And then what was P? It was AX, which was 3X in this example. So you're going to substitute AX back, the 3X back, because P is not even a variable that was in your original trinomial anyway, right? So we're just going to put it back to make it look like the original equation again. So substitute 3X into P, and you get 3X minus 6 times 3X plus 4, right? So as long as they're equivalent, you can substitute it back and forth how many times you want. And in this case, it really helps you to substitute a simple variable in there, single variable in there, and then substitute it back with whatever your AX was, okay? And then you can factor out common factors, which seems to be 3. It's gonna be your A, your coefficient, okay? And that's gonna be, that could be taken out here. Okay, so now, one more question. Why can't we just take out 3 and get rid of this 3? Why can't we do that? Because if you are trying to solve this out, if you multiply 3 out here, then you don't multiply, 3 is gone. Like, you don't have to multiply 3 again to this factor, right? So when you factor out 3 out from one binomial, then that's fine. And if you're multiplying everything together, it's still gonna be multiplied to one factor at a time, right? So yeah, unless you have another factor to factor out from your next binomial, you can just factor out the greatest common factor from one binomial, and that's fine. Okay, step 5, your last step. You're going to multiply. Since you started by multiplying the trinomial by A, you're going to divide it to make it simplified, which is because we actually changed our polynomial, right? We multiplied 3 in the beginning, which changes our value. If this whole thing was equal to 1, would equal to 1, we multiply 3, we got 3, right? So 3 is not equal to 1. So we changed the polynomial. We need to put it back. How do we do it? We undo by doing the opposite of what we did. Multiplying 3 can be undone by dividing it by 3. Okay, so we're going to divide everything by 3. And that just means we get rid of that coefficient 3. And the factor form for your original product, polynomial is x minus 2 times 3x plus 4. Simple. It is a lot of steps, but if you are more comfortable using substitution instead of by grouping, this is another method that you could solve, okay? All right, so let's try number 3A and B. See if you can draw it by yourself and come back when you're ready for answers. Okay, are you ready? All right, if you're ready, let's check your answer. So first, let's look at 3A. 2x squared minus x minus 6. You're gonna solve it using substitution. So before you use the substitution, what is the preparation process? We need to make it desirable to substitute, right? We're first gonna change the polynomial. Like what? Yeah, we're gonna put it back later. We're gonna promise to put it back later and then do it later. So first we're gonna multiply the coefficient A, which is 2 in this case, okay? So multiply 2, and you have 2 times the whole thing, 2x squared minus x minus 6. And so that's gonna give you 2x parentheses squared minus 2x minus 12. And then we're going to assign a variable. Let's say 2x is equal to y. Okay. And then we're going to substitute 2x by y. So we have y squared minus y minus 12. And now it's easy to factor out, right? So factor this out. The factors of negative 12 that could add up to negative 1 would be positive 3 and negative 4, right? So y plus 3 times y minus 4 would be the factors. And then we're going to substitute this back, right? So remember, y is equal to 2x. So we're going to have 2x plus 3 times 2x minus 4. Remember, we have to divide 2 to undo what we've done in the first place, right? To get to our original equation. So let's factor out the greatest common factor. 2x plus 3 is good. It cannot be factored, but 2x minus 4 can be factored by 2, right? And you have x minus 2. And so now you can divide 2, which means you just get rid of that 2. And the factors, the remaining factors, 2x plus 3 and x minus 2 would be the factors that that would be equivalent to your original polynomial. Easy. So multiply your coefficient a, substitute back, and divide by the coefficient a, okay? So we're gonna make it more complicated and then put it back together. And then it's gonna be factored out when we simplify this, okay? That is the summary of substitution. Let's look at part B. It's the same process. 10x squared plus 3x minus 1. We're gonna multiply 10 to the polynomial. And then that just means we have 10x parentheses square plus 30x minus 10. And you're gonna have a substitution for 10x. So 10x could equal to a. You can literally pick any variable that you like, okay? And you have a squared plus 3a minus 10. Easy. That would be factored out to a plus 5 times a minus 2. And then you substitute it back. A was equal to 10x, right? So that's equal to 10x plus 5 instead of a plus 5. And 10x minus 2. And then you have to divide it by 10. So figure out the greatest common factor. It turns out that you have a 5 for GCF for your first term. You have 2x plus 1 remaining. And then you can also factor out 2 from your second binomial. You have 5x minus 1 remaining. So 5 times 2 is already 10, right? So you can simplify this to 10 times 2x plus 1 and 5x minus 1. And then if you divide it by 10, the factors you're left with are 2x plus 1 and 5x minus 1. What if you got 5x minus 1 and 2x plus 1? They're the same thing. You know, multiplication. In multiplication, you have the commutative property where you can change the order and it will not change your answer, right? So it's okay if your orders are different as long as you got the same factors. If you have 2x plus 1 and 5x minus 1, then you got it correct. Check your answers and see if any of the process got you. All right, so those are the methods. Those are the methods to factor out polynomials, trinomials that have a coefficient other than 1 for your first term. Let's summarize our lesson. Factoring ax² plus bx plus c where a is not 1. You can use factor by grouping, or factor using substitution. So it looks like you have a lot less steps in factor by grouping, but it might be hard to understand at first, okay? So you might be tempted to use substitution all the time, but please remember that they're both useful, okay? Sometimes factoring by grouping is a lot easier than substitution. Sometimes substitution is actually easier, even though it's a lot of steps, than grouping. So it depends. Make sure you know all methods, both methods, okay? Factoring by grouping, you are looking at the product of the first and last coefficients that add up to 22, and you're going to break them down, break the second term down so that you can group them and factor them out and factor them out again using distributive property, okay? Factoring using substitution, you're going to multiply your coefficient and then substitute it with a variable, and then you're going to substitute it back after you're factoring it out. And then you're going to divide the coefficient that you multiplied in the first step. Okay, so those are the summary of what we learned in this lesson so far. Please review the vocabularies. The important vocabularies that were mentioned in this lesson were binomial, monomial, quadratic, trinomial, and trinomial, okay? So you should be able to understand that a quadratic trinomial in the form ax² plus bx plus c, when a is not equal to 1, can either be factored by grouping or factored by substitution. That was lesson 7-6, and we'll continue with the next lesson in the next video. Thanks for watching, guys. Bye. Keep up the good work.